All right, everyone, let's start. Seawater is basically a mixture of different salts. And in that salts, we have a concentration of chloride ion, which is 20 gram per dm cube. Okay. The exact concentration of chloride ion in seawater can be determined by titration with aqueous silver ions. And obviously is going to be the precipitation reaction, because when silver ions and chloride ions react together, obviously silver chloride is formed. And the equation for this reaction is going to be like this. Okay. Well, for this titration, we need to use aqueous potassium chromate 6 as an indicator. When aqueous silver nitrate is added to a sample of seawater, silver ions reacts with chloride ions so that white precipitates of silver chlorides are formed. Okay. One more thing. This potassium chromate 6 is basically an oxidizing agent also, and its nature is carcinogenic. So it causes cancer. Okay. One more thing. Silver chloride has white precipitates, and also silver chloride is insoluble in water. Okay. When all the chloride ions has reacted with silver ions, the presence of unreacted silver ions is detected, and that statement shows that silver ions has to be in excess. Silver ions must be in excess. All right. By chromate 6 ions, a red precipitate of silver chromate is seen. So that's the end point of the titration. You will get red precipitates after the titration, and that's the end point for this. And the equation for this red precipitation is going to be like this: when silver ions reacting with chromate 6 ions converting into silver chromate. Again, silver chromate is an insoluble salt. The amount of silver ions reacting with chloride ions in the sample of seawater can be calculated in order to determine the concentration of chloride ion in the sample of seawater. A student uses the following method. Use a weighing board to weigh by difference approximately 10.6 gram of silver nitrate into the 100 cm cube of glass beaker. Now, what kind of a so basically what we want is that mass of empty board, let's suppose, is 10.5 gram. Then mass of board plus AgNO3 is going to be 10.7 gram, and obviously mass of silver nitrate is going to be 10.6 gram. Okay, so that's the meaning of this statement. Now the next step is use the sample of silver nitrate solid in the glass beaker to prepare 250 cm cube of silver nitrate. In order to prepare this solution, obviously I will use volumetric flask for that. Transfer this solution into a dark brown glass bottle. Label this solution X. Now the main question is, why are we using dark brown glass bottle? So this has a lot of reasons. Silver ions has a very is very sensitive to sunlight, right? So if I need to increase its shelf life, I need to put it in the dark brown glass bottle. Also, silver ions can reduce in the presence of sunlight to silver matte. So to avoid this reduction reaction to sunlight, we need to place it in the dark brown bottle. Also, you can say to increase the shelf life. Also, to increase the shelf life of silver nitrate, okay? Also, you can say that silver ions can reduce in the presence of sunlight. That's called photochemical reaction. And because of that photochemical reaction, it undergoes reduction so that you will get silver metal. And because this will reduce the shelf life of the silver nitrate, so in order to increase the shelf life of silver nitrate, we need to place it in the dark brown glass bottle. I hope it makes sense to you. Now, the next step is collect the sample of seawater and remove any solid material present. Uh, how can I remove solid material present? So we have multiple stages in that. I mean, I can use filtration technique, flotation technique, or sedimentation technique, or desalination, in fact. But I think I'll go for the filtration technique because it is much easier in the lab. Transfer 10 cm cube of the seawater into the conical flask. How can I transfer this volume? And obviously, it's a 2 decimal place, so it must be accurate. So obviously, I'll go for the volumetric pipette. I will use volumetric pipette to measure this volume. Volumetric pipette is used to measure this volume. Okay. Add 1 centimeter cube of potassium chromate to the conical flask. And now the problem is this is the indicator. And how can I add this much amount of indicator into the conical flask? And obviously, I'll go for the micropipette. So use micropipette to measure 1 cm. Use micropipette, also called teat pipette, to measure this volume. Rinse a burette in the preparation for this titration. Okay. And obviously, for titration, I need 250 cm cube conical flask. Fill the burette with solution X. Slowly add solution X to the conical flask until white precipitate turns red. This is the end point. That's what I've told you initially when I started this question. Let's see what we have. Okay. Describe how the student should carry out step 1. include a table in your answer to show how this process is recorded. Okay. First of all, we need to weigh the mass of empty weighing boat. Empty weighing boat. All right. Then I need to transfer silver nitrate into the weighing boat until 10.6 gram has been recorded. Then transfer silver nitrate into the weighing boat until 10.6 gram reached. After that, I need to transfer this 10.6 gram of silver nitrate into a 100 cm cube of beaker. Transfer 10.6 gram of silver nitrate in 100 cm cube beaker. Then I need to reweigh the weighing boat for the measurement of the accurate mass. To reweigh the empty boat, to get the accurate mass to be calculated. All right. Now I need to make a table on the basis of this. So for table, I think I'll go for this. Mass of empty weighing boat in gram, then mass of boat plus silver nitrate in gram, then obviously mass of silver nitrate in gram. Let me all right, that's the table. Now the next part of the question, which is very, very important, describe how the student should prepare 250 cm cube of silver nitrate in step 2, starting with the silver nitrate in 100 cm cube beaker in step 1. That's a very, very simple format. We have done a lot. We have done this a lot of time in paper 5. So we need to make the solution. And for that, I'll use the volumetric flask for that, okay? So what we can do is first dissolve 10.6 gram of silver nitrate into 100 cm cube of beaker by using small amount of distilled water. So dissolve 10.6 gram of silver nitrate in 100 cm cube beaker and add distill water in it to dissolve it properly. Now in the next step, I need to stir the mixture to mix well. After stirring the mixture, transfer the solution into a 250 cm cube volumetric flask. cm cube volumetric flask. Also, I need to wash this beaker with distilled water and transfer this washing into this volumetric flask. Wash the beaker with distilled water. And transfer this washing into volumetric flask. All right. Top of this flask with distilled water. Dropwise. Till 250 cm cube mark reached. Shake the flask thoroughly to mix well. Now the next is suggest why solution X is kept in a dark brown glass bottle in step 3 rather than in the colorless glass bottle. I've told you about that. Silver ions can undergo photochemical reaction. All right. So reduction of silver ions will give silver metal. Also to increase the shelf life. Suggest how the solid material should be removed from the seawater in step 3 through filtration. Identify the most appropriate piece of equipment that you would use to transfer 10 cm cube of seawater volumetric pipette. Add 1 cm cube of potassium chromate into the quantity flask micropipette. or T pipette. Chromate 6 solutions are known to be carcinogenic. That's what I've told you initially. State what precaution should be taken when using potassium chromate in step 6 rather than wearing safety goggles. Always wear the chemical resistant gloves or nitrile gloves. Wear chemical resistant gloves. Or nitrile gloves. State what the burette should be rinsed with in step 3. Obviously, burette should be rinsed with solution X or solution of silver nitrate. All right. It's a lengthy question, guys. How much marks? Oh, 18 marks, which is why it's very lengthy. The student obtained the results shown in table 1.1. So we have initial and final burette readings for certain titrations, and we need to take out the titer values for each. So the titer value for this is going to be 23.40. The titer value for the titration one is going to be 22.35. Then 22.60, and then 22.45. Okay. That's my guess. 22.45, 45.05 minus 22.60. Yeah, 22.45. So calculate the mean titer used to calculate show your working. So I think I'll go for these two titration because they are very close. Okay. So mean titer (22.35). So we need to add these two values to get the titer value, average titer value. And 22.45 divided by 2, so you will get what? 22.40 cm3. So 22.40 cm3. So that's the rough titration. You can cancel it, you can ignore it. Now we have three values, so we need to compare which one is more consistent, which one is more concordant values. I believe these two values are more concordant and consistent as compared to this one. So I need to ignore it again and use these two values to get the mean titer. All right. Now by using this mean titer from H2 to calculate the concentration of chloride ions in the sample of seawater, assume mass of solid silver nitrate used in step 2 was 10.62 grams. So first of all, I need to find out the moles of silver nitrate by using the mass of silver nitrate. So mass, oh my goodness, moles of silver nitrate is basically 10.62. Oh no, 10.6. I think 10.6. That was 10. Yeah, that was 10.6 gram. Okay, not 10.62. So 10.6 divided by the MR of silver nitrate, which is going to be 170. So I believe 0.0624 moles of silver nitrate are present. I know silver nitrate and silver chloride has 1:1 ratio, which means that the molar ratio between silver nitrate and chloride ion needs to be 1:1. If you know, silver nitrate and chloride ions are reacting together, converting into silver chloride and nitrate ions. C. Both of them has 1:1 ratio. All right. So it doesn't make any difference. All right. So if you have 0.0624, obviously the moles of chloride ion would be same. Which is 0.0624 moles. All right. So I've got this moles in 250 cm cube. 250 cm cube in 250 cm cube, guys. Okay. So in 250 cm cube, we have 0.0624 moles. Now, what was the titer value? That was 22.40. So how much moles in it? So it's going to be 5.59 into 10 to the power minus 3 moles. Okay. Last but not the least, I need to find out the concentration of chloride ions. So whatever the moles of silver ions in 22.40, we have the same number of moles of chloride ions. So we have how much volume we have taken? We have taken 10 cm cube. All right. Okay. Okay. First, um, I've dissolved this much mass into 250 cm cube of volumetric flask, and from this solution, I took 10 cm cube. All right, and placed it into the conical flask for titration. All right. So in 10 cm cube of chloride ion, the moles would be same, 5.59 into 10 to the power minus 3 moles. In order to calculate the concentration, we need to compare it with 1000. So concentration is going to be 0.559. All right. Calculate the percentage error in the titer in the titration tool. The volume of titration 2 is 22.60. I need to get the percentage error. But one thing you need to remember, and I've told you so many times, that the error in single reading for burette is 0.05 cm cube. So for percentage error, I need to multiply 0.05 times 2 because we take initial and final burette readings divided by the titer value of titration 2, which is 22.60 into 100. So it's going to be how much? 0.44%. So 0.44% is the right answer. Spectroscopic analysis of the sample of the seawater accurately determine the concentration of chloride ions to be lower than the determined by titration with silver ions. Suggest why the student's method give a higher value. कुछ और ions भी available हो सकते हैं. So some other ions are also present in seawater which can react with silver ions thereby error in titration. Okay. So that's the end of question number 1. I hope it makes sense to you. Let me know if you find any error in this. Let's start question number 2, guys. A student wants to investigate the rate of the hydrolysis of methyl methanoate. First of all, methyl methanoate is an ester. So technically, we are discussing the rate of hydrolysis of an ester. All right. Second thing, this ester is formed when methanol and methanoic acid are reacting together. Okay. The structure of methyl methanate has to be like this. So this is the acid part, all right, and this is going to be the alcohol part. So this comes from methanol, and that comes from methanoic acid. So that's the equation, guys. That is methyl methanoate hydrolyzing with water, converting into methanoic acid and alcohol. That's a reversible reaction. You should remember this. Reversible reaction are those in which rate of forward and rate of backward are equal. The reaction is catalyzed by dilute hydrochloric acid, and obviously it is acting as a catalyst. That's the catalyst. So catalyst takes part in the chemical reaction. Also, it will recover at the end of the reaction. So we need to focus on both the aspects in this question most likely, all right? The amount of methanoic acid produced as the reaction progresses can be monitored by titration with aqueous sodium hydroxide. Obviously, we need to titrate these two substances. And obviously, we should know the concentration sodium. Okay, and for this titration, we need thermolphthalin as an indicator. Remember thermolphthalin indicator? This indicator is colorless in acid and blue in alkali. So this indicator shows blue color in alkali while it will remain colorless in acid solution, all right? To determine this, the volume of NaOH needed to neutralize H ion from the catalyst needs to be found beforehand. Okay, one thing. This volume of NaOH, the concentration of NaOH can be changed because it can react with the atmospheric carbon dioxide. And the reaction of acid and alkali is basically an exothermic reaction. So because it is an exothermic reaction, obviously energy is being released. And if energy is being released, obviously that's going to be the rise in temperature also. And if the temperature is rise, obviously this will change the concentration of NaOH. It will absorb more carbon dioxide during the reaction. Okay, so that's very important aspect of this reaction. So what we can write here is the reaction of alkali and acid is exothermic. This will rise the temperature. And if this will rise the temperature, so NaOH can react with atmospheric carbon dioxide to give sodium carbonate. So this can change the titration result. So this can change the titration result. So we need to be very careful. Either we need to place a stopper all the time on the NaOH. The student uses the following procedure. Add approximately 150 cm cube of ice water to a 250 cm cube conical flask A. Why are we adding ice water in it? We are adding ice water just to slow down the reaction rate. To slow down or quenching or quench the reaction rate. All right. Since the reaction is exothermic, so it releases heat. If it releases heat, obviously, solution is going to be solution is going to be more uh, is going to be heated, as it will absorb energy. So this will break the container due to thermal stress also. All right. And also we need to control the temperature. There are a lot of aspects for this quenching for ice water in the solution to control the temperature or to maintain the temperature. All right. At 200 cm cube of 0.2 mole per dm cube HCl into a 500 cm cube conical flask, which is Blee. Conical flask B is the flask in which reaction takes place. Transfer 2 cm cube of 0.2 mole per dm cube HCl from the conical flask B to conical flask A. Carry out the single titration of the content of conical flask A with NaOH of known concentration. And that's how I'll get the concentration of hydrogen ion. So concentration of hydrogen ion can be determined most likely by using step 3. With this step, okay, add 10 centimeter cube of methyl methanoate to a conical flask B. How can I add 10 cm cube of conical flask? Obviously, I can use burette or volumetric pipette. Both can be used. And how can I add such a small volume? And obviously, I'll go for the micropipette. Okay. Swirl the reaction mixtures. Why are we swirling the mixture? To mix well. Or so that all parts of the solution will get uniform heat and immediately start a stopwatch. After 1 minute, transfer 2 cm cube the reaction mixture from conical flask B into conical flask A. Carry out further single retitration of the content of conical flask A against NaOH. Do not empty the content of the conical flask A between titration. After 10 minutes, transfer 2 cm cube the reaction mixture from conical flask B into the conical flask A. Titrate the content of the conical flask A against NaOH. That's a simple thing. Repeat step 6 at an interval of 10 minutes for 1 hour. State which step is used to determine the concentration of hydrogen ion. That was step 3. Okay.
So part B is the iced water in conical flask A is used to significantly reduce the rate of reaction. So in flask A, we have ice water, and this ice water basically decreases the temperature. So it lowers the kinetic energy, effective collision, and therefore rate of reaction increases. But technically, ice water is used to quench the rate of reaction, which I've told you initially when I was explaining this, right? So let me write this. Flask A contain ice water which lowers the temperature for esterification. So this reduces kinetic energy effective collision. All right. So now the issue is suggest two reasons why the rate of reaction is significantly reduced. So this is the first reason why the rate of reaction is significantly reduced. Second reason is that flask A contain how much amount? 150 cm³ in conical flask, whereas flask B contain whereas flask B contain 2 cm³ of HCl, right? So flask A has larger volume, flask B has lower volume. So that is going to be the change in concentration of when a unit time increases, and this reduces the rate of reaction. So flask A contain large amount of water. That is around 150 cm³. Compared to 2 cm³ of flask B. So this decreases the concentration. So this lowers the concentration. And lowers the effective collision, hence reduces the rate of reaction. All right, I hope it makes sense to you.
Oh, let's move on to the next part, part C. Table 2.1 shows the reading taken by the student. Okay, we have readings, time in minutes, total volume of NaOH needed to neutralize total amount of H plus ion. VT, what is VT? VT is basically VT. What is VT? Okay, so VT is the volume of NaOH in cm³ used to neutralize H plus from methanoic acid at time t. All right, and V infinity minus VT. What sign is that? V infinity or something sign like that. So volume of NaOH in cm³ used to neutralize H plus ion from methanoic acid at 60 minutes. Okay, at 60 minutes. Okay, so first of all we have 11.40. So I need to subtract all these values from this to get the VT. Okay, so what we can do is 12 points minus 11.40, 17.70 minus 11.40 minus 11.40 minus 11.40. I need to subtract all the values from this. 11.40 minus 11.40. So I'll get the VT, that the volume of NaOH used to neutralize H plus ions from methanoic acid at time t. So it's going to be how much? 1.2, 6.30, 8.50, 10.70, 13.50, and obviously 14.50. So when time was 60 minutes, the V proportional or V infinity is going to be 14.50 because at 60 minutes I'm getting this volume. Okay. So this is going to be 14.50 cm cube. All right. So I need to subtract this value and this to get this. So technically what I'm saying is I need to subtract these two values in order to get this answer. Okay. So 14.5 minus 1.2 is going to be 13.30. 14.50 minus 6.30 is 8.20. Then 6.00. Then 3.80. 1.00, and obviously this is 00. Okay. Since examiner is using the two decimal places, so I think I need to give answer up to two decimal places. 1.20 would be the right answer. Okay. Identify the independent variable. I've told you so many times, dependent variable, what we measure, whereas independent variable, what we change. So what are we change? What are we changing? We are changing time. All right. We are changing time. So time is going to be the independent variable. Also, the independent variable could be the total volume of NaOH because I'm changing it. Okay. Identify one variable that needs to be controlled apart from the concentration and volume of solution, obviously temperature, because reaction is exothermic, so we need to maintain the temperature. All right. Next is reading 2 should have been taken at 10 minutes and not at 13 minutes. State whether this result should have been included or not. Explain your answer. Yes, it should have been included. Why? Because consistency in volume used by methanoic acid and remaining volume of NaOH, because it is showing consistency in volume used by methanoic acid and remaining volume of NaOH. All right. Also, rate of reaction depends on time. Also, rate of reaction depends on time because it changes linearly. Depends on time. Okay. Oh my goodness, graph. So I think we need to plot a graph on the grid and we need the line of best fit. Okay, line of best fit. And use the cross to plot each data point. What we can do is I need to sketch this so that I can make my graph easily. Okay. All right. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right. So that's the scale. And we have 1, 2, 3, 4, 5. We have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. I hope it makes sense to you. So what sort of scale we have? So we have V infinity minus Vt on the y-axis. So that is going to be on the y-axis. And Vt is basically has to be on, time has to be on the x-axis. Okay. So time is going to be the independent variable, guys. That's what we have decided in the last page. How much time initially? 1 minute. So that's my 1 minute. And at 1 minute, we have 13.12, 13, 13.2, 13.4, somewhere around here. Okay. That's my first point. Then at 13 minutes, we have 8.20. 13 minutes, 8.20. 10, 11, 12, 13. 13 and 8.20. 8.2 here. 11, 12, 13. This is going to be 8.2. Okay. Then my next is at 20 we have 6, 10, 20. This must be. Then we have 33.80. This is 10, 20, 30, 33.80. 3 are 2, 4, 6, 8. This much. 2, 3, 2, 4, 6, 8. This one. Okay. Now the next is 50. Oops. At 30. Oh, 40 is missing. All right. So we need to find out the volume at 40, obviously, in the question in the later part. At 50, we have 1. At 50, we have 1. And at 60, we have 0. That is going to be my. Oh, so that's not the straight line, basically. It's the curve of best fit, I must say. That's not the best fit line. That's not even possible. Yeah, that's the best I can do. And obviously these 2 points, this point is very close to this. Let me check this value. At 20 minutes, we have 6, right? So 4, 5, 6. Yeah, yeah, it's right. It's fine. At 30, we have 3.80. At 30, we have 3.80. This is 3. This is 2, 4, 6, 8. Yeah, it's fine. It's fine. That's the only sketch I can make with such an accuracy, or I can make it through, I think that's the best one. Or rather, I'll go for that. What do you say? Is it fine or no? It's not. It doesn't look good at all because of this. I think the previous one was fine. Oops. Okay. Let me do it again. That's the best. I think that's the best. Yeah, that's the best. There's a curve of best fit, not a line of best fit.
All right, part 6 is reading 5 was not taken. All right, that means we need to find out that reading. Use the graph to predict the total volume of NaOH. We need to find out the total volume of NaOH. And what is the total volume technically? Total volume, total volume of NaOH is basically the volume of methanoic acid used for neutralization, also the volume of HCl used for neutralization. And what about the volume of HCl? The volume of HCl is 11.40, which is used for the neutralization right? So it's basically we know the volume of HCl, but we really need to find out the volume of methanoic acid. So let's find out that. How can we find out? Let me read the question again. Needed to neutralize the total amount of H plus ion at 40 minutes. Total amount of H plus ion. So total amount of H plus ion at 40 minutes. So at 40 minutes, not gonna work like this. Yeah, makes sense. Makes sense. Yes, this is 2.4, I believe. 2.4, yeah. This is 2.40 cm3, and this is going to be V infinity minus VT, guys, because we have V infinity minus VT on the y-axis. So 2.40 is basically V infinity minus VT, and we need to find out the volume of NaOH used for the neutralization. So what we can do here is that V infinity minus VT equals to 2.40. V infinity, this V infinity is basically 14.5, right? So V infinity is 14.50 minus, we need to find out the VT and 2.40. Now VT is basically 14.50 minus 2.40. So it's going to be how much? Let me calculate. It's basically 12.1 cm3, right? And this is the volume of NaOH is used to neutralize methanoic acid. Is used to neutralize methanoic acid. So I know the volume of NaOH used to neutralize methanoic acid. I know the volume of NaOH used for neutralize HCl. Both the values are known now. So in order to get the total volume of NaOH, the volume of NaOH used to neutralize methanoic acid is 12.1. Volume of HCl is given in the back data, which is 11.40. So 11.40. So total volume is going to be how much? Total volume is going to be 12.1 plus 11.40. So 23.5 is basically the right answer for me. Okay. I hope it makes sense to you.
It is not possible to repeat the experiment, state whether the data from the experiment is reliable, justify your answer. I think this point and this point is basically and little bit this one. So out how many points we have? 1, 2, 3, 4, 5, 6 points. Out of 6, we have 3 almost I think it's not. The sum of the points are not on the lie or curve of best fit. No, because some points are not on the curve of best fit, this is because more NaOH has been added. That's one of the reason. Or volume is transferred early, or stopwatch start too early or too late. So that could be any reason. So we have only one mark. So we can write, I've given you 3 reasons. So we can write only one. All right. That's the end of this paper also. Thank you very much, guys.